All right, so these notes are going to be a continuation in your foldable. What we're going to be talking about is ions. So the question is, what are ions? We've been talking a lot about electrolytes and how electrolytes are charged particles. Well, a chemist would call an electrolyte an ion. They're one and the same. So anything that claims to have electrolytes is really just something that has ions in it. Now, ions and electrolytes, being the same thing, can have the same definition. They're both just charged particles. And we've seen a lot of evidence of charges, the movement of charges, and how charges can have positives or negatives, which goes to say that some ions, I'm going to change the size of my font, some ions are positive because overall they have more positives within them than negatives. Let me illustrate with a plum pudding model. Let's say this was our particle. A positive ion might have 1, 2 positives within it and only 1 negative. Overall, the charge of this particle is going to be positive. We would call this ion a special name to denote that it has a positive charge. We'll call it a cation. I like to remember that cations are positive because, well, it's kind of funny. Cats have paws. Get it? So they're positive. Anyway, you'll never forget it if you remember that. So cations are the positive ions, and then some ions don't form positives. Some ions overall are negatively charged. And that means that these ions have more negatives within them than they do positives. So perhaps this ion has 2 positives and 3 negatives. Overall, the charge is going to be negative for this ion. We would call this ion that's negative an anion. If you can remember that cations are positive because cats have paws, you should be able to remember that anions must be the only other ion left, which is negative. That being said, not all ions form the same exact charge. Let me explain. So some ions form charges of different magnitude. So, for example, let's say we had an ion looking like this that had 1, 2, 3 positives and 1, 2, 3, 4 negatives. Overall, this ion is going to be an anion because overall it will have a negative charge. But how much negative charge will it have? If I have 3 positives and 4 negatives, the magnitude of my charge is going to be -1. So in other words, this is an anion that has a -1 charge. Let's look at a different example. Let's say we had an ion that had 1, 2, 3, 4 positives and only 1, 2 negatives. This ion would be a cation because it's positive overall. Oops, my tool is still on, it would be a cation, because overall this ion is going to have a positive charge. There are simply more positives than there are negatives. In fact, there are 4 positives and 2 negatives. So the magnitude of this ion's charge isn't just going to be +1. The magnitude is going to be +2. You see, +4 and -2 combined yield a magnitude of +2, meaning that this ion's charge, this cation's charge, is +2. So I can have some cations that are very positive because they've got a very large magnitude, and then I can have some cations that aren't as positive because they've got a smaller magnitude. Every element has a different magnitude. Oops, I don't want to go too far off screen. So elements on the periodic table form charges of different magnitudes. So what we're going to do in our next activity is try to determine what charges the elements on the periodic table form. And maybe, are there patterns to the charges that elements form on the periodic table that we can use to keep us from having to memorize all of those different charges? That being said, you're ready to move on to the activity, so go ahead and progress forward.